Hello, year 12. So we have been informed that you're going to have a telecommunication problem in your area these days. So I decided to record this video so that you can always go back to this lecture whenever your telecommunication problem is already fixed. Okay, so let me share my screen. So let us begin this discussion with the assignment that I gave to you. And you were tasked to answer exercise 6C, numbers 125, pages 160 to 161. So I hope you were able to answer this. And please check your own papers. Okay. So we have here a fair six-sided die is rolled. Find the probability that the first time a 6 comes up is on the first roll, on the third roll, before the third roll, or after the third roll. Okay, so first and foremost, we need to define our distribution. So X is a geometric distribution where our P is, so we have a six-sided die. The probability that 6 will come up would be 1 by 6. So that is our P is 1 by 6. So our Q is 5 by 6. So to answer I, probability that 6 will come up on the first row. So we are looking for probability that X is equal to 1. So that will be going back to our formula. That is P sub R is equal to P multiplied to P minus 1 raised to R minus 1. So if our R is 1, so this is our R. So substituting that would be P sub 1 is equal to, our P is 1 by 6. And P minus 1, 1 minus P, not P minus 1, I'm sorry. That is 1 minus P. Which is our Q is 5 by 6 raised to 1 minus 1. Or that is 1 by 6 multiplied to 5 by 6 raised to 0, or that was equal to 1 by 6. Now for II, we're going to look for the probability that 6 will come up on the third row. So that would be P sub 3 is equal to 1 by 6 multiplied to 5 by 6 raised to 3 minus 1. So that is 1 by 6 multiplied to 5 by 6 raised to 2. Okay. Or that is 1 by 6 multiplied to 25 over 36. Or that is equal to 25 over 216. Then for I, we're looking for the probability that 6 will come up before the third row. So that's the probability that X before, so that is X less than 3. So in finding this, we need to find the probability that X is equal to 1 plus the probability that X is equal to 2. 3 is not included, so we'll stop at X is equal to 2. And probability that X is equal to 1, we already have solved that. That is 1 by 6. Probability that X is equal to 2 is 1 by 6 multiplied to 5 by 6 raised to 2 minus 1. Or that is 1 by 6 plus 1 by 6 multiplied to 5 by 6. Or that is 1 by 6 plus 5 over 36. Or that is equal to 11 by 36. Now for 4, we are looking for the probability that 6 will come up after the third row. So that is x is greater than 3. And we know that x is greater than 3. It will take us solving for lots of parameters. So instead of solving this, we can use the complement. That is 1 minus the probability that the complement of greater than is x is less than or equal to 3. And probability that x is less than or equal to 3 would be the same as probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3. Or that is 1 minus, we already have computed x plus x equal to 1 plus x equal to 2. That is this one. So that is 11 by 36. And probability that x is equal to 3, we also have computed that in II. So that is plus 25 over 216. So we have 1 all over 1 minus 216. So we have 66 plus 25. Or that is 1 minus 91 over 216. Or that is equal to 125 over 216. So for number 1, give yourself 1 point each if you got these answers. Then let's go to number 2. We are talking about here about a fair three-sided spinner, and we are interested with getting a 3. Okay, so let us define our distribution. So x is a geometric distribution wherein the probability of success is 1 by 3. So again, P is 1 by 3. So therefore, Q is 2 by 3. So in I, we're going to find the probability that x is equal to 1. So that would be equal to 1 by 3 multiplied to 2 by 3 is to 1 minus 1. It's going to be 0. So that is equal to 1 by 3. Then for II, probability that x is equal to 5 would be equal to, again, this is probability P of 5. So that is 1 by 3 multiplied to 2 by 3 raised to 5 minus 1. Or that's 1 by 3 multiplied to 2 by 3 raised to 4. Okay, or that is 1 by 3 multiplied to 16 over 81. That should be 81. Or that is equal to 16 over 243. Now let's solve for III. We're looking for the probability that x is greater than 5. Okay, so this is, again, we'll be solving lots of parameters if we'll be using this. So instead of this, we'll use the complement. That is 1 minus probability of x is less than or equal to 5. So this is like solving for 1 minus probability of x is equal to 5. Probability of x is equal to 4. Probability of x is equal to 3. Probability of x is equal to 2. Plus probability of x is equal to 1. So this is 1 minus, we already have computed this in II. So that is 16 by 243 plus x is equal to 4 would be 1 by 3 multiplied to 2 by 3 raised to 4 minus 1. X is equal to 3 would be 1 by 3 multiply to 2 by 3 raised to 3 minus 1. X is equal to 2 would be 1 by 3, multiply to 2 by 3 raised to 2 minus 1. And X is equal to 1 is we already solved that in I. So that's 1 by 3. So this is 1 minus 16 over 243 plus 1/3 multiplied to 2 by 3 cubed plus 1/3 multiplied to 2 by 3 squared plus 1/3 multiplied to 2 by 3 plus 1/3. So we have 1 minus. So we have 16 by 243 plus we have 8 over 81 plus 4 over 27 plus 2 over 9 plus 1 by 3. So we have here 1 minus all over 243. So that would be 16 plus 24 plus 36 plus 54 plus 1. Or that is 1 minus 211 over 243, which is equal to 32 over 243. Okay, so give yourself 1 point each. You're able to get this. Let's go to number 3. So we have here a game reserve run safaris. Okay, and then experience has shown that on 1 in 4 safaris, a tiger is seen. So let us define our distribution. So X is a geometric distribution wherein the probability of success is 1 by 4. So again, P is 1 by 4 and Q thereby is 3 by 4. Okay, so we're going to find the probability that is I. So I would be probability that he does not see any tigers. So that's probability that X is equal to 0. And we know that Camille goes on 5 safaris. So therefore, he wasn't able to see a tiger on those 5 safaris that he went into. So therefore, this is going to be 3 by 4. So all of it is a failure raised to 5. So that is 243 all over 1024. Okay, let's go to II. Probability that he sees at least one tiger. At least one tiger. So this P is greater than or equal to 1. Again, this is difficult to solve. So instead, let us get the complement. So that's 1 minus probability of X is less than 1. And we have solved this already, right? No, not yet. Or are you sure? Let's see. Probability that X is equal to 1 is equivalent to the probability that X is equal to 0. So see, we already have computed that in I. So that's 1 minus 243 over 1024. Or that is equal to 781 over 1024. Let's go to III. The first tiger he sees is on his last safari. So it's going to be at the last safari, so that would be X is equal to 5. That is his last safari, right? So we have here 1/4 multiplied to 3 over 4 raised to 5 minus 1. So that is 1 by 4 multiplied to 3 by 4 raised to 4. Or that is equal to 3 raised to 4 over raised to 5, which is equal to 31 over 1000. No, not 31. That's 81. 81 over 1024. So let's go to 4. he does not see any tigers on his first 3 safaris. So if he does not see any tigers on his first 3 safaris, so that would be a failure, right? So that would be 3 by 4 multiplied to 3 by 4 multiplied to 3 by 4. And he sees them on the 4th and 5th. So that would be a success. So that's 1/4 multiplied to 1/4. Let me fix my writings. So we have 1 by 4 multiplied to 1 by 4. So this will give us 27 over 1024. Okay, so give yourself one check each here. Okay, so you count the number of checks. For 5, we have 4 marks. For 2, we have 3 marks, so that will give us 7. For number 1, we have 4 marks, so we have a total of 11 points. Okay, so total for this assignment is 11 points. So count the number of checks and then comment your score in our Google Classroom. Okay, now let's proceed. Okay, still our topic is geometric distribution, wherein our objective is still using formula for the probabilities for the geometric distribution, and we will be also talking about the expectation of the geometric distribution. Okay, so let us review first the difference between binomial distribution and geometric distribution. Okay, so a binomial distribution, so this is our connotation for a binomial distribution. This is how we represent it, where n is the number of trials and p is our probability of success. Okay, for binomial distribution, the number of trials is fixed at the start. We already know that is our n, right? And then the number of successes are counted. That is, there are a combination of n taken r ways to obtain r successes. Okay. Now for geometric distribution, which is represented by this, that is x, distributed geometrically, where p is our success. The number of trials are repeated many times as necessary until the first success occurs. Okay, so there's a probability that's going to be infinite. Okay, and there is only one way to obtain the first success on the rth trial. That is, there are r minus 1 failures followed by a success. Okay, let us have a sample problem. Imagine you are threading a needle. The probability you thread it on each attempt is 0.3. Find the probability that it will take you more than 5 attempts to thread the needle. So let us define the distribution first. So we have a geometric distribution wherein our success is 0.3. So that is P is 0.3. So therefore our Q is 0.7, right? Okay, now to solve this, okay, for there to have, okay, more than, right, more than 5 attempts. So for there to have at least 5 attempts. Okay, we're going to have 5 attempts. Then there must have been 4 failures, right? Because you cannot go to a 5th attempt if you were not able to experience the 4 failures. So therefore, the probability that x is greater than or equal to 5 is equal to 0.7 raised to 4, which is equal to 0.0256. Okay, We have a theorem to explain this. So we have a probability of success after the R trial. So that is X is greater than R is equal to Q raised to R. Okay, so don't forget that. Always remember that. Probability of X is greater than R is equal to Q raised to R. And the probability that X is greater than or equal to R, that would be Q raised to R minus 1. Okay, so don't forget that. Let's have another one. Example, you are threading a needle. The probability you thread it on each attempt is, so we have the same problem. Okay, so we have a geometric distribution. Our success is 0.3. So that is P 0.3 and Q now becomes 0.7. Find the probability that it will take you at most 7 attempts. Okay, again, we can actually think of this in a clever way. Okay, so that is for there to be at most 7. Okay, 7 attempts. Okay. We can think this as the complement of at least 8 attempts. Okay, so therefore, the probability that X is less than or equal to 7 would be equal to, you get the complement, that is 1 minus the probability that X is greater than 7. Or that is 1 minus 0.7, because we have defined that one here, greater than 7, greater than R is equal to Q raised to R. So that is Q raised to R, and our R is 7. Okay. So therefore, it is equal to 0.9176. Okay. Actually, we have another, you need to memorize this, that probability of X is less than or equal to R is equal to 1 minus Q raised to R. If there's no equal sign, that is equivalent to 1 minus Q raised to R minus 1. So take note of this. Okay, let's have another example. In a particular country, 18 of adults wear contact lenses. Okay, so let's define our distribution. So X is a geometric distribution wherein our P is 0.18. So again, 0.18 is our P, so thereby our Q is equal to 82, 0.82, right? Okay, so what are we going to looking for? Find the probability that the first adult who wears contact lenses is one of the first 15 interviewed, and not one of the first 9 interviewed. Okay, so solve for A. One of the first 15 interviewed would be probability that X is less than or equal to 15. And we know that we can write this as 1 minus Q raised to 15, or that is 1 minus 0.82 raised to 15, or that is equal to 0.949. Okay, so see, once you understand it, the computation would be very, very easy. Probability to the first adult who wears contact lenses is not one of the first 9 interviewed. So if it's not one of the first 9 interviewed, we are looking for x is greater than 9. Okay. And in the previous theorems, we know that this is equal to q raised to 9. Okay. So that would be 0.82 raised to 9, which is equal to 0.168. Okay. Let's have another one. A coin is biased such that the probability of obtaining heads with each toss is equal to 5 by 11. So defining our distribution, probability of success is 5 by 11. So therefore, probability of failure is 6 by 11. Okay, so what are we solving? Find the probability that the coin is tossed at least 6 times and fewer than 8 times. So letter A, at least 6 times would be x is greater than or equal to 6, right? Which is equal to q raised to 6 minus 1, which is equal to q raised to the 5th. And we know that q, let's indicate it already. Q is 6 by 11 raised to 5. Okay. And 6 by 11 raised to 5 would give us 0.0483. Okay, let's go to letter B. Fewer than 8 times. So probability that x is less than 8. Okay. So that would be equal to 1 minus q raised to 7. Or that is 1 minus 6 by 11 raised to 7, which is equal to 0.986. Okay, so let's now talk about the expectation of a geometric distribution. So that is E of x, which is also equivalent to the mu, which is our mean. Okay, so in solving the expectation of geometric distribution, that is simply equal to 1 over p. So we have here 1 in 4 boxes of Zinco breakfast. So let us deny our distribution. It is a geometric distribution wherein the probability is 1 by 4. So that is P is 1 by 4, Q is by 3 by 4. Okay. So letter A, find the expectation of X. So that is expectation of X is equal to 1 over P. And we know that P is 1 by 4. So therefore, the expectation of geometric distribution is equal to, is now equal to 4. Okay. Now, interpret the value found in part A in the context of this question. So in interpreting that, we can say that on average, because that is a mean, right? On average, a child will find their first toy in the 4th box that they open. There you go. That's how we interpret it. Let us have another example. The variable x follows a geometric distribution. Given that the expectation of x is equal to 3 and 1/2, find the probability that x is greater than 6. Okay. So we have E of x is equal to 3 and 1/2, which we can write as 7 by 2 is equal to 1 over p, right? So therefore, we'll have 7p is equal to 2, or P is equal to 2 by 7. Okay. Now we now have P, so we can now know Q, and Q is 5 by 7. Okay. So we are looking for the probability that X is greater than 6. Okay, from our previous slides, we know that this one is equal to Q raised to 6. So that is 5 by 7 raised to 6, which will give us 0.133. Okay. So that would be all. Let me give you your assignment. So for your assignment, please answer exercise 6C, numbers 4, 7, and 8 of pages 160 and 160 to 161. Okay, so please submit this on time in our Google Classroom under classwork. Okay, that will be all. Thank you. Bye. See you next meeting.